Whenever there's a period change or a phase shift, I like to make my cheater graph. Put that on my chair, please. So I'm going to make a cheater graph because I see that we have a phase shift. That is whenever there's adding or subtracting inside of parentheses to the x. There's nothing multiplying to the x, so we're set up. We just have to go left pi. So let's see, what does my cheater graph look like? A cheater graph, I call it a cheater graph because it has no numbers. I get to make the numbers myself. Now normally, my sine function starts and goes like this, right? This is my sine function. So my sine function usually starts right there at the origin. But if I'm going, whoa. But if I'm going left pi, what would this point go to? If I move this point to the left pi, what would it go to? It would go to negative pi. Okay, let me give you another picture of this. Normal sine function goes like this. And if this was negative pi right here, we would be moving this line back so that it goes like this. Like we would be shifting it. Like everything would move back pi. So on my cheater graph, I'm just going to start my point at negative pi. And because I'm pretty fancy with graphing sine, I know that whenever I graph sine, I need 1, 2, 3, 4, 5 points. I have 1, 2, 3, 4, 5 points. Okay? And that's so that's my cheater graph right there. So let's put the rest of the x's on my cheater graph, and then we'll take care of the midline change, which is a vertical shift, and the amplitude. Okay, so how do we know what our last number is? Well, we would have to know the period. Since there's nothing multiplying to the x, we're just going to take the normal period, which is pi. You would divide it by 1, but that doesn't make sense to do right there. So we need to go 2 pi this way. So what would we be at? What number would we be at if we go 2 pi that way? This is negative pi. Yeah, we would be at 1 pi. So I'm going to put a pi sign right there. And the rest of these numbers aren't as bad to find as other problems are. Actually, the rest of the numbers are pretty simple to find. So what's the number in between negative pi and positive pi? 0. Good. And then we have pi over 2 in between 0 and pi, and negative pi over 2 in between 0 and negative pi. There's another way to find that out. If you are starting with another number that's kind of wacky, like not negative pi, that's a nice pretty number. But if you're starting with like a fraction or something, and then you have to find out where you end up, then you would take the period, in our case is 2 pi, and you would divide it by 4. So when I do that here, I get pi over 2. Why would I divide it by 4? I would divide it by 4 because I have to add it 1, 2, 3, 4 times until I get to my last number. And actually, adding pi over 2 works in this case. Check it out. What's negative 1 pi plus pi over 2? Well, it would be negative pi over 2. Negative pi over 2 plus pi over 2 would be 0. 0 plus pi over 2 is pi over 2. Pi over 2 plus pi over 2 is going to be pi. So are you guys still tracking with me?
Yes.
Okay. So I'm a little extra when I explain it, guys. I'm sorry, but I want to make sure you guys understand the ins and outs of everything that I'm doing. Now that I have the numbers, which is the hardest part in my opinion, I need to do the midline change and then my amplitude. And I like to go in that order, okay? So my midline change, instead of this being the x-axis, I'm going to make this the 3-axis. And then if I have an amplitude of 3, that means I would have to count up 1, 2, 3. What's going to be that number? 6. And now I have to count down 3. 1, 2, 3. What's going to be that number? 0. So now I have to graph my 5 points. Okay, at this point I already have the midline, and then I have the max, and then I have the midline, and then I have the min, and then I have the midline. Whoa, bam. Okay, now let's look over at my graph, my scaled graph. This is not a cheater graph anymore. I like to start out with my midline when I get on here. What is my midline?
3.
It's at 3. So draw a line right here, that's my midline. And then I start trying to find the points that are on my cheater graph over here. Now, over here, we don't have any negative x values. We stop at 0. So negative pi and negative pi over 2, they're out. But what about 0?
Yeah.
0's there. And actually, 0 is right on the midline. Right? Since this is my midline right here, 0 is right on the midline. And then I go to pi over 2, which is our next x value, and I have to go down to 0. And then I go back to the midline at pi. All I'm doing is I'm copying these points right here. Those points I just copied onto my regular graph. But now, do you guys know the pattern? Can you finish graphing on the rest of this graph?
Yes.
See, what would be next? I know we'd be at this x value. What would be next? A midline, max, or min? Max. You're right. And then we go back to midline, then we go min. And then we go back to midline, and then we go max. And then I connect all the points, and I've graphed my function. It's very important, guys, that you make it curvy. Now, it looks like we start going down first, but that's not true. Before x equals 0 at x equals negative pi, that's when we go up. Because normally that's where you start with sine, right? You go up to the max first. But because this part is not on our graph, you're only seeing this part. You're not seeing this stuff that's happening before. So it looks like we're starting we're starting to go down. But because of the shift, we're really still starting up, but it just looks like we're going down.
So in order to do this right, we have to do all the stuff before.
Yeah, the shifting, whenever there's a phase shift, like the horizontal shift, that's the hardest one. Like if I didn't have a phase shift or a period change, I don't need a cheater graph. It's very simple to move the midline up and then change the amplitude.
So if the 3 wasn't there, we don't have to do the before stuff, kind of thing.
If the pi wasn't there. Yeah.